Hello students, in this video I will show you how to compute the p-value using the binomial distribution instead of the normal distribution. The p-value that will result is going to be an exact value for the p-value instead of using an approximation with the normal distribution. The question is question number 5 from homework number 13. We wish to test the following claim that the alternative hypothesis suggests that the proportion is greater than the initial proportion that is mentioned in the null hypothesis at a significance level of 5%. We have the sample size 204, and we have x is equal to 138, the number of successes. And we would like to compute the p-value. Now I'm going to go to an Excel sheet and explain to you. I have x138, n is equal to 204, and the probability is 0.56. Now I don't need to compute d hat or z naught because I'm not using the normal distribution. So usually when we talk about the binomial distribution, this is what I usually tell you to do. I usually tell you to build a table, but building a table here is not going to be beneficial. I'll try to explain it here. So I'm assuming that I'm going to build a table that's 0 and then it ends at 204. And then I have the number 138 in the middle somewhere. So basically this is a right tilt test because p is greater than 0.56. So if I'm talking about a normal distribution, then 138 will be right here, and I want to find the area here. The area is all of the sum of those numbers right here. But if I use the binomial function accumulates from the top. That means it's going to compute the 0, and then it is going to add the probability of 1, and then it's going to add the probability of 3, and etc. Basically, if I'm going to use the binomial distribution, it is going to accumulate all of these numbers if I wanted to stop at this number. So I want to find the area for p-value. So I will do 1 minus binom dot distribution, and it's going to ask about x. So for x, I'm going to say take away from the 1 because if we add all of them, the answer is going to be 1. The probabilities, if you add them, it's going to be 1. So 1 minus this piece right here will give you the rest, which is what we're looking for. But if we accumulate all of these and include the 138, that will not give us an accurate value for p-value because we will be missing the probability of 138. And that's why we're not going to start with 138. We're going to start with 137, comma, the sample size is 204, and the probability is 0.56. And we're going to accumulate in this case, so we're going to choose true instead of false because we're not building a table. We're accumulating right away. So I will compute the p-value using the function that I just wrote down. The p-value is equal to 1 minus binom dot distribution of 137, comma 204, comma 0.56, comma true. 56 right here. That is the answer. I'm going to copy that and paste it and round it to 4 decimals. And the answer is that one. This is how you're going to compute the p-value, and I trust you that you can answer the rest of the parts in this question. I hope this video helped you, and I will see you in a different one.